Hey, welcome back, class. This is week three's video. It was nice to see everybody last week. It was good to put names with faces finally. This week, what we're going to be doing is we're going to be working with solving algebraic expressions. So just putting in numbers for those variables and solving to get an answer. And the reason we're working with this is that algebra can be used in so many different areas. It opens the door for you for many different concepts that are everyday life situations, but also for your future career choice, right? So before I've been asked, why do I need to learn algebra? What's the point? Why am I doing this if I'm never going to use it in life? But really, you will. You might not really think you're doing algebra, but in the back of your mind, you'll be so good at it that you're just doing it automatically. But really, it is algebra. And some situations that you might run into in the future is some of you have a cell phone or you are going to get a cell phone, or when you're older, you'll have to pay for your own cell phone plan. Trying to figure out a cell phone plan and comparing prices, not only for cell phones, but any good or service that you might do, right? If you need to hire a plumber or have a contractor come and work on your house, right? Anytime you're doing a price comparison, technically what you're doing is you're doing algebra, right? Another thing is that in the future, if you want to buy a house or if you want to buy a car or if you have a credit card or even if you're trying to save money, loans, interest rates, which we'll talk about later in the year, but all of those things deal with algebra as well, right? So, yeah, you might not do algebra when you're, I don't know, eating breakfast or something. That's fine. That's normal, right? But you are going to be faced with situations where you're going to have to find an unknown amount, so a variable, and you're going to have to figure out the answer. Some of you guys like to hunt, right? Well, hunting is a regulated sport. And the reason it's regulated is because if anybody just went out and just bagged as many deer as they possibly wanted, right? Then our deer population would be at a steady decline. We need people like the DNR to go in, issue out permits, issue licenses to go out and hunt these deer. That way, the population can have a steady increase, but you guys can also go out and enjoy the sport of hunting and bring back some deer during the holiday seasons and hunting season and all of that. So that's a regulated, but what's it regulated with? Algebra, because there's variables, there's unknowns that are needing to be solved in order to keep the population at a steady level. And then maybe your first job might be somewhere at like McDonald's or Sheetz or Wendy's or maybe at a fast food restaurant. That's awesome. And maybe you might not be doing algebra at the front counter, right, at a cashier, but I would hope all of you would be able to strive to becoming a manager one day. And managers, what they do, yes, they work with their employees, but they're also in charge of talking about how much food do they need to order, looking at price comparisons, and trying to make sure that the business is running properly, right? That's algebra. So it's not always going to be you're sitting there with a pen and paper and you're putting X's and Y's in problems, right? But problem solving and trying to find unknown amounts is algebra. So all of you in some way are going to be using these lessons in your future. What I want us to do is to take algebraic expressions, the type of expressions we were working with 2 weeks ago, and we're going to finally put in a number for that variable and solve it. All right, so let's hop into our lesson. There's not many new vocab words for this week's lesson, but one of the most important ones is this word right here that says substitution. Now, I want each of you to sit and think. If I were to say, this upcoming week, I'm not going to be there on Tuesday, I'm going to have a substitute, what does that mean? Hopefully you're thinking a substitute is coming into the classroom. That means Mr. Dotson's not here and somebody else is in place for Mr. Dotson. They are the substitute. So in algebra, when we say we're substituting a number, what we're doing is we're taking out something and putting something else in. Okay, something comes out, then something else goes in. So let's look at this example and see how substitution plays a role. It says Eric collects miniature cars. He has one large case that has 20 cars. He has He also has 3 same size smaller cases filled with cars. Let n equal the number of cars in each smaller case. How many miniature cars does Eric have if each smaller case holds 10 cars, 12 cars, 14 cars? So if we look over here, let me choose a color. It gives us our algebraic expression. It says 20 plus the product of 3n. So that just means 20 plus 3 times n, right? Because anytime you have a variable next to a coefficient, a number, it means multiplication. So here's where substitution comes into play. It says how many miniature cars would Eric have if these smaller cases, 1, 2, 3, could hold 10 cars? We'd have to figure out that amount. Well, what if those smaller cases could hold 12 cars, 14 cars? So we need to substitute in these values in for our variable. So our variable is n, and what we want to do first is to substitute in each one of these values. So it would be 20 plus 3 times, let's start with 10. So we take out n and we substitute in 10. Order of operations, we want to do multiplication first. 3 times 10 gives you 30. And then we bring down this plus 20. And 20 plus 30 is 50. So if those smaller cases could hold 10 cars each, then that means in total Eric would have 50 cars. So now that we solved for 10 cars, let's solve for 12 cars. So instead of substituting in 10, let's substitute 12 in for our variable. So it should be 20 plus 3, I'm going to put parentheses, 12. Same as up here, we want to start with multiplication first. 3 times 12 gives you 36. And then we want to bring down the plus 20. And when you add both of them up, your sum is 56. So when we substituted in 12, our answer was 56. We took out the variable n and we put in a number, a value for it, and we just solved it. So we got 10. We got 12. The question asks us now to do 14. So let's change colors and let's try what would happen if we substituted in 14. So it would be 20 plus 3n, that's our algebraic expression. Now we want to substitute in 14. So n comes out, 14 goes in. So it should be 20 plus 3. I'm going to write parentheses to show multiplication. So 3 times 14. Multiplication first. 3 times 14 gives us 42. And then we bring down our plus 20. So 20 plus 42 gives us a sum of 62. So do you see how if we put in a value for n, you get different answers? So depending on what n is, gives us a different answer. If n is 10, our answer is 50. If n is 12, our answer is 56. If n is 14, the answer is 62. So your answer will change based off of what the value of n equals. Okay, so that's what we're going to be working on this week, is that we're going to be evaluating algebraic expressions with different values for our variable. Let's try some more. So here's another example of how algebra plays a role in our everyday life. If you've ever heard of a car's miles per gallon, right? MPG, what that is saying is how far can that car go per gallon that it drives, right? So for an example for you, my truck that I have gets about 22 miles per gallon, which means that I can drive 22 miles on 1 gallon of gas. Some smaller cars, like smart cars, can get an upwards of 30 to 40 miles per gallon, which means they can go double the distance I can in my truck on 1 gallon of gas. Motorcycles, dirt bikes, same thing. They would be able to go a lot farther on 1 gallon of gas than I would in my truck. Okay? Another way to think of it, the larger the vehicle, the more, or the less distance it can go on 1 gallon of gas. So like an 18-wheeler uses up a lot of gas based off of how far it goes, whereas a small car like a smart car or a Prius or something can go a lot farther based off of 1 gallon of gas. So let's look at this example. It says Julie's family took a 4-day trip. Julie's mother wrote an equation to calculate their gas mileage, M, in miles per gallon. Let D equal the number of total miles driven on the trip, and let G equal the total number of gallons of gas used for the trip. So here's our equation. M equals D divided by G, because remember, whenever you have a number over top of another with a bar in between, it's a fraction, which is technically division. So it says, what was the gas mileage for the 4-day trip? So what we need to do is figure out what is the gas mileage for each one of these days, and we'll be able to figure it out. So if we're going to find the average here, what we can do, if it says day 1, day 2, day 3, day 4, it gives us the miles driven that day and how much gas was used in gallons. So if we add each of these up, so we add all of the miles and then we add all of the gallons of gas used, we can find the average miles per gallon usage. So what we're going to do is we're going to add first these miles up. So when we add them all up, 476 plus 439 plus 382 plus 263, you get 1,560. So that means that they drove 1,560 miles in 4 days. Now we want to add how much gallons of gas was used. So when we add up 15, 13.5, 15.4, and 16.1, we get 33.4. So that means that in total, they used 33.4 gallons of gas. So the letter D represents the number of total miles driven. So that's our purple number. So we have 1,560. And we want to divide that by 33.4. And that will give us our miles per gallon. So 1,560 divided by 33.4. Remember that a fraction is just division. And when you do divide these out, you get 26. So the vehicle, MPG, miles per gallon. So the vehicle that Julie's family used gets about 26 miles per gallon. So that's better than my truck. So that's not too bad. But that's how we figure it out. We just take how many miles were driven, divide it by how many gallons of gas were used, and it gives you the MPG. All right, so this is algebra. We wanted to find an unknown amount. So we used this equation over here, and we solved for M. So M equals 26. So another situation you might run into in the future is when you do get a house, or if you have an apartment or whatever it might be, right? You might want to redo, let's say, your kitchen tile. And in order to do that, you need to measure out how much space you have in your kitchen, and you want to make sure that you don't overbuy new tiles, or you don't want to have too little amount of tiles so you have to keep going back to the store. It would be nice if you measured and solved and you got the exact amount that you need. That way you can just do it all in one trip and you're good to go and you don't waste any money. All right. So it says Mr. Grant wants to tile a 27 square foot area with square tiles. Let S equal the side length in feet of a square tile. Use the expression, and it says 27 divided by s squared, so s to the second power, to find the number of tiles Mr. Grant needs to buy. So if Mr. Grant has a kitchen, let's say it's this big, right? And the total space of this kitchen, the area is 27 square feet. So not too big, but not too small. But he wants to put the exact amount of tiles in here. In order to figure out how many tiles he needs for his kitchen, is he wants to take his total area and divide it by the square footage of one tile. And over here, it says that the square footage of a tile is 1/3 of a foot. So using this expression, 27 divided by s, well, s equals 1/3. So we're going to substitute in 1/3 for s. So s comes out, 1/3 goes in. So it should be 27 divided by 1/3 squared. And if you remember when we were working with exponents, squared does not mean multiplying it by 2. It means multiplying the base by itself 2 times. So this is really 1/3 times 1/3 because there's 2 1/3s. That's what it's saying. So 1 times 1 is 1. 3 times 3 is 9. So this is 27 divided by 1/9. Now, if you remember, when dividing by a fraction, here's a tip. Keep, change, flip. So I'm going to put a 1 underneath of my whole number. I'm going to keep that the same. Division changes to multiplication, and the reciprocal of 1/9 is 9/1. 9/1. So there's my new problem. I changed division to multiplication, and got the reciprocal of 1/9, which was 9/1. We multiply fractions straight across. So 27 times 9 gives you 243. And then 1 times 1 is just 1. So it's 243/1. If we simplify that, since this is just division, your answer is 243. So using a little bit of algebra, Mr. Grant now knows exactly how many tiles it's going to take to complete his, let's say it's a kitchen, 27 square foot kitchen, right? He doesn't overbuy, he doesn't underbuy, he has the exact amount, 243. So we've been looking at some real world examples, the past few examples, but this one is really what you're going to be working on for your homework assignment for this week. And what it is I'm going to give you an algebraic expression, and then I'm going to give you a few, so either 2 or 3 numbers to substitute into that algebraic expression to get an answer. So let's try this one out just so you have something to refer back to. It says evaluate the expression 50 minus t times 2 when t equals 10, 20, or 25. So I'm going to put me down here. This is what we would do. First thing I would do is write the expression 3 times. Since I have 3 values I'm going to test, I'm just going to write out the expression 3 times so I know I have 3 problems to solve. I don't forget any of them. So now that I have my 3 expressions, let's first look at the values that I'm going to substitute in. The first one is 10. So I'm going to take 10 and I'm going to substitute it in for t. T comes out, 10 goes in. So now it should say 50 minus 10 times 2. Order of operations, I want to do my parentheses first. So 50 minus 10 gives you 40. And then 40 times 2 is 80. So when you substitute in the value of 10 for t, your answer is 80. Now what I want to do is substitute in my next number. So let me go to green, which is 20. So instead of t, I substitute in 20 for t. T comes out, 20 goes in. So we have 50 minus 20 times 2. Parentheses first, 50 minus 20 gives you 30. Then just 30 times 2, which is 60. So when we substituted in the value of 20, we got an answer of 60. All right. So here's something to think about, right? As our value for t went up, what happened to our answers? It went down. So just to triple check, when we do substitute in the value of 25, if our answer is less than 60, then we should be on the right track. But let's find out. T comes out, 25 goes in. So 50 minus 25 in parentheses. Don't forget the parentheses. Times 2. Solve parentheses first. 50 minus 25 gives us 25. And then the last step is to multiply it by 2. 2 25s gives you 50. So when our value for t was 25, our answer was 50. And 50 is less than 60, so our pattern is true, and we're good to go. Okay? So real quick, before we end this lesson, I want to go over, just in case, and I'll do this in class too, but just in case you're watching this video because you didn't come to school, these are your assignments for this week. You have the 3-5 practice problems. The way it works, right, it's similar to the last problem we just did, but be careful because it says evaluate the expression with the given values. X equals 1, y equals 2. So I gave you the value for x, so you substitute in 1 for x, and then I gave you the value for y, which is 2. So you substitute 2 in for y. So once you plug in those numbers, then you just solve the expression just like normal. Okay? So you're going to be doing that for all of these problems. So take your time, and if you need any help, let me know. Now, the other assignment that you'll see inside the folder, and it says you do not need to work on this at home. You do not need to. The reason I put it inside Schoology is just in case anyone is absent. We are going to be working on this in class. I'm going to give you a paper version of it. By chance, if you're not there, I do want you to either print it out or you can work on this digitally by using Kami. Whatever works, it's fine by me. Right? You can open the assignment with Kami if you're logged into your Google account. Either way is fine, but I just want you to know you don't have to do this assignment if you're going to be in school, okay? When we're in school, we'll work on this together, and then I'll grade it, and then I'll put the grade into Schoology for you. So you don't have to submit anything for this unless you're not at school, okay? So that's all I have for you for this lesson. I hope you all are doing great. If you need anything, please remember you can message me on Schoology, or I still have my office hours on Wednesdays. Hop on in at any time. I'll be happy to help. So, as always, until next time in the next video, stay safe, stay healthy, and I'll see you all soon.